start to add some relations. So we're going to say David's body is grafted onto James's body. Now we're going to maybe pop open the developer widget at the bottom of the web page, and we're going to start looking for the this and the that, right? This on the David page, the that on the page. So we're going to find a selector that represents David's face up here. And this is kind of a gnarly selector, but it works. Now we're going to go to James's page, and we're going to find a selector that represents his face. It's also kind of a gnarly selector. And I chose this example because of that. We're going to see how to pick it up in a second. And then we're going to write our first relation that's really going to swap something. So we're going to say David's image here, and the ampersand source is selected with that, is James's image down here. So this is just one relation. And if we proceed in this way, then what we'll see is we'll need one graph around the whole thing. We'll need an is for every field, an R for every list of something, and an if exists to cover up areas where there's a schema misalignment. So you always have this schema alignment problem, especially if you're doing some post-hoc alignment where people are just naturally going to have this sort of page. Okay, so here's the result. If you follow this through and write all these relations, here's the two different pages. So essentially what we would have done then after constructing the sheet is we add that link just like CSS into the head of David's page, loaded in the browser with this library, and we actually see the David's page map out to the side. Okay, but let's go back to this first selector here. This looks not those are really nasty. And if I were asked to either copy and paste every content field by hand or write these selectors, I'm not sure which one I would choose. So part of this is because we're doing this post-hoc adaptation. David's page and Landay's page weren't made for kind of designed around this reason. Like David's page doesn't see it so.
I don't know if those newfangled ideas.
Okay. So let's see what we can do if we try to work with this method and actually like author in advance, trying to see what we can do, knowing that tree sheets may exist. And I'll talk about three ways we can leverage this. So one is mock-up driven design. One will be about encapsulation. And then one will be about microformats and post-hoc. Okay, so once David's page is related to Landay's page, we kind of are faced with this interesting possibility. Why not just remove all of the extra crap from David's page, all of the design page stuff, just strip it down to the bare bones necessary. Look at 1990, and then let James worry about the design. And if we were to do, the point is, David's page is pretty simple, but simple pages can be complex too. So I just picked a random MIT course page and then scan through its source. So here's the source that represents just the sidebar. So even Spartan pages can have a lot of this design scaffolding. So let's say we collapse this down to very simple content. We kind of enter this regime where we've got two documents now, and one represents just this Spartan set of content. One represents this design model. And then we can relate them via one of these tree sheets. So when you really take this apart, this is actually interesting when you compare it to the existing template. So the content document is essentially a data object in the template regime. But here it's just regular HTML. And the design document is a design object. And in the template regime, it would be one of these code objects. But here it's also just regular HTML. They both render fine in the browser. You can directly manipulate them. You can edit them with a WYSIWYG editor. But you still get these nice properties for order like design updates and for even casting up slides. So we did a quick test because the intuition from this as well is to be much easier to edit. So we found 3 course pages online that seem to be handy. And we created 2 variants. One we just took a regular course page. One we split it. We stripped one down into this content HTML, bare bones possible. And we created tree sheets so it would look like this. Created some participants, and then we had to perform these tasks. So we would say, find the 10th, the 4th course announcement and modify the type. Or find the 5th course announcement. here's what the interface looks like. And probably unsurprisingly, you see that when you separate the concerns, you get much better performance, much quicker to locate portions of the HTML, manipulate portions of the HTML, understand what's going on. Okay, so the second topic is microformat versions. So microformats are this notion for the semantic web community. And the idea is sort of this. For some class of users, rather than ask them to alter RDF, what if we were to come up with curations of CSS classes that they could apply, and that would act in the stead of some RDS? And so it would be an easier way for people to signal that there was a particular kind of data on the web page, kind of extract that data and map it onto some nodes. So with microformat means we're signaling that there's this data confused, but with this we can reapply that same concept and actually start to theme without the need for any kind of theme. So let's say we start creating a professor theme. There's the theme tree and the theme tree. And we know at the very least professors have names in labs and films. And maybe they have some publications in each publication. And what you see here is the situation where we have the symmetric classes on either side. And they only differ in the tree names, and we're leaving those tree names unmapped. And so now maybe we publish the sheet for them. And the only thing that an implementer needs to do, that a professor might need to do, is find those trees. So maybe there's some fancy professor and everybody likes his webpage. So you would link to this professor theme file. You find the mean tree to your page. This is the pointer to the current page. You find the theme tree to the fancy professor's web. And all that fancy professor needs to have done is use the same CSS classes, and you can perform all of the rewriting in the tree to DOMs for design. Or maybe MIT publishes one that's a standard template for all professors. And maybe Carnegie Mellon poaches you. And so you go to Carnegie Mellon, but you don't have to change your web page, you just rebind this one single line page to the other exemplar design. So this is theming by example now because of the existence of this tree sheet. So through this microformat, we're able to route from any one page that also uses the microformat. So we did an experiment. We mapped a couple of professor pages all into a common microformat. And just some interesting observations we had while doing this exercise. We could flip back and forth after we did it. So two observations were, one, again, this schema alignment problem. You're going to post hop to this to a website. You're going to run into the situation where you're wrapping everything in condition. Maybe one person posts on a students will get posted on projects on a certain page. And so different numbers of rules are going to be active in the process. And then the second thing we noticed that was kind of an interesting observation was just the prevalence of commingling content within a document. So in order for, we're using CSS selectors for making tools. CSS selectors have to be able to select a node. So if you commingle maybe your first name and your title of a single document, then in order to actually participate in one of these things, you're going to have to modify the structure of your document. It's not as simple as just adding. Simple as adding. And just here's anecdotally how it's for the number of modified.
So you're saying that I had best structured
Best structured. It might be because we started with the schema. So I just want you to imagine how we might run with this. I mean, on the one hand, it's a relatively simple wish, but imagine if every website was a theme. All you had to do with this data was add a few CSS classes, and every person who made the website was a theme publisher. Because today could be a theme publisher. Think of all of the interesting data domains that don't have these, simply because they require content management systems. So we have this kind of, or imagine that just portions of the website too. So today we have this situation where, kind of by historical accident, themes are a dependency of content. To use a theme, you need to use WordPress. And that locks us into this very funny situation from the standpoint of people wanting to express ourselves. And it makes you want to ask the question, is the reason we have no professor themes, is there no professor? This model lets us this backwards pointer. Remember that this is what theme files look like. Programming. So next I'll talk about encapsulation. And another way to look at this activity here is that there are particulars of James's design that are hidden by a layer of the reference. So one way we can look at this is that the teacher is providing encapsulation. This layer. So today we have this weak encapsulation. We link to CSS. That's great. Link to JavaScript. It's not a specific file. As if you had to take the C standard library. And people who use Twitter Bootstrap may remember it. This is a big problem. So Twitter Bootstrap is this widget library that people use on the web. And like any piece of code for the web, the implementation consists of these one part CSS, one part HTML, even though it can be HTML. And so if you implemented the humble horizontal form widget, then you updated the next version of Bootstrap. Link to CSS. You would get broken rendering, and the reason was because you have to copy by value the HTML. So you have to go through and find every place in your website. And not only find every place, but go look for this particular patch and find instances of this pattern and replace them. So it's not just about fixing encapsulation. There's several ways you can do that. But about finding a standard way to make it easier to package. So here's the D3 website. It's a great example of beautiful visualization. If you click on one of these examples, click on that guy right there. This is how they suggest you reuse that. It's an enormous amalgamation: HTML, JavaScript, CSS. And even as a programmer, you have to spend 5, 10, 20 minutes staring at this thing, understanding what's going on and how do I get my data. So another thing we did, this was our years ago, was to show that you can pretty trivially wrap all of these D3 widgets with tree sheets. Then you just link to the CTS file in the head. And then you could, for example, instantiate a word cloud just by adding a class. Now, it's not about making it possible. They're all Turing machines. The D3 folks have chosen to do the programming. Of course they do this. But it's about baking in this kind of reuse into the core layer so that it's very easy and straightforward. And we implemented, this is another interesting exercise, a few of these D3 widgets. And just one interesting thing to think about is all of the things you save yourself from having to understand. So if we tested them in, for example, WordPress. So if you're a journalist and all you know is how to use WordPress, and you want to make a core club widget, well, it may be a little silly to make a table inside your GUI and write Virginia 32, Massachusetts 48. But if you do that, now you can just make a core club. So let's talk about this final piece, which is adding data. We're going to go back to this question of how would you add a new publication from your web content. Remember, the problem here was that the machinery we have at our disposal that describes how things go forward doesn't tell us anything about how things should go back. So wouldn't it be nice if there was if we could use the same set of relations? So I could edit something on my website, and then edit, the changes to the DOM would trickle right back into the database and the files cause that thing. So it turns out that the relational approach, the way that we define it, enables this data flow bidirectionally. And the reason is there are these two properties that I didn't really mention. The first is that the relations are symmetric. So if you go back to the definition of is and are, so, what you'll see is that it doesn't matter in which direction you execute. You're fine to work out the way. And then the second is that the tree manipulations we're doing as a result of these relations don't destroy the relations themselves. We're going to call this property lossless. And the trick is pretty simple for this. So if you look at is our graph and exists, all of them were relations on parents that only modify the subtree of the parents. And so what that means for us is that we're going to have a set of trees. Maybe one is data, maybe one is land-based design, maybe one is floor. We have a set of relations that are relating all of these trees. So the rendering process that takes us to this new tree that we're going to see retains the property that all of the relations responsible for the creation of the solution are on nodes in the set of trees back here in the forest that also got written into TF. Okay, so we can simply copy the relations to this output tree as we render. We can add the output tree back to the forest. And now we've got a forest that contains that output that's in your browser, but it's still related with all the provenance information back to all of the trees that we use proposed to create your output. So we can go in either direction when a change happens on either one. So now we just need this react. So we have the forest and all of the relations. Some edit happens to a tree. Maybe a node is removed, maybe a node is changed, maybe a node is inserted. And we need to produce an edit script for all of the other trees. And that edit script is going to be based upon the structure of the trees. We're going to implement this with an event model. So any change is fully contained within some node. And we're going to propagate that change up the tree. And then we're going to send it to any related nodes. And here we're going to do something a little bit funny. We're going to say it's up to that tree to figure out how to handle it. But it's going to have access to some information. It's going to have access to the relation responsible and the related node. Remember that this can go either way. And here's why we're going to say it's up to this tree right here. It doesn't matter what tree we're working with. It could be HTML, it could be JSON, RDF, it could be a spreadsheet. As long as it understands how to manipulate itself in response to the relation, sending it a message in a particular edit, add, change. Then, it can do whatever it wants to its internal structure. So any data structure could be integrated into the system as long as it exposes its data as a tree, resolves the selected language, handles events presented to it, and then throws events. So one interesting observation about this is related to output. So today, when we program these read-write applications, design this static web page site is a little more easy to copy. But think to something like Facebook or Twitter. What you see is there's a lot of machinery and magic stuff. It's all private. And you see this web page that's kind of compiled, and it's basically assembly language compiled. When you start doing it this way, then everything that you need to copy and paste and reuse is public. It's outside the wall, so that you can pick up and modify. So we implemented the modifications necessary to do this. So you can go to the website and you can use whatever you want. HTML5, content editable, or using JavaScript widget. You just start editing the page. And then it will trace back the provenance and send those messages, even when it hooks on the server, like that, to write to the tree. So if you edit the title, or edit the file that represents the content, if you edit the design, and modify the file. Okay, so we go, where can we run with this? And a good place to run with this is to something that allows for more data modeling. So spreadsheets are still one of the most popular data management tools. They just work, and we all know how to use it. And so spreadsheets are great at data modeling application. They don't really have a UI that's very flexible. HTML has a UI that's really flexible. It's distribution method. It doesn't have data modeling and computation unless you're going to be a programmer. So we adapted that for spreadsheets. So we wrapped the little spreadsheets in the tree, so it changes the tree. And then we created a selector language. So the spreadsheet already has a selector language for us, A1. We added some new concepts, allowing you to address the spreadsheet as a table of items in the database style. So you can talk about it as a table of rows or a column. We're going to try to resolve different selectors to the column headers or the row headers. So you can talk about this row, column A as tags. There's a number of different ways you can do this. This is the way that we did it. You can think of all sorts of interesting ways to address a spreadsheet. So here's an example of some statements you might say. So my page H1 is the A1 cell in some spreadsheet. Or my page UL are the rows in some spreadsheet. And another interesting twist, which is kind of an aside, is that it turns out you can collapse the is-are graph relation. Just have this one relation. So think back to the R relation. One of the reasons why we needed to have this R separate from the low-level graph relation is that fundamentally we don't know what type, what semantic type the HTML element is. Does that mean set? Does that mean here? one single block. The spreadsheet, we do know exactly the semantic role. Something's either cell or set of nodes. And so for a couple reasons related to that, the symmetric effective relation is symmetric. We can just give you this one relation because triple root. It's a simplification that you'll see in later slides. So the result is you can make an HTML mockup. Basically, your to-do list, just an HTML design mockup. Create a spreadsheet, and then write the relations to relate the two, and then you change one and the other changes. So we did a user study with this. 15 HTML beginners, 40% had used, or just to give you an example of kind of the level they were at as a proxy variable, 40% had never seen the table element, 66% had never used the total. So just kind of getting started with HTML. We give them a 15-minute learning session. We taught them the three relations that exist in this variant system: connect, show it, and hide it. And we talked about things like data modeling. Sometimes you want to talk about cells. And then we give them 4 app building tasks. Task number 1 was build a mortgage calculator. Task number 2 was build a to-do list. And for these 2 tasks, we gave them the HTML, gave them the spreadsheet. And the reason we assume they know how to write HTML, so they know how to write spreadsheets. So what we wanted to see was if they could connect. Think the alternative case, Ruby on Rails programming case. The hard part is all this machinery that's required to take data back. So that's what we wanted to see. So halfway through, everybody was doing a little too well at this. We got really nervous that we'd given them something too easy to do. And so we upped the ante just a little bit, and we started introducing 2 more tasks. So one was a chat room, one was a math wizard. And for these tasks, we only gave them the HTML, and then we didn't give them the spreadsheet. So we said, here's a mock-up of a website. Create the spreadsheet necessary to back the data model. It's write all the functions and connect it up. So here's the answer key for the to-do list, so you have an idea of what they were writing. So we gave them the HTML mockup, and we gave them the actual HTML right here. And so with this spreadsheet over here, all we have to write are these 5 relations right here to connect the HTML to the spreadsheet. You see, because we collapsed is our graph, basically just connect. That's what you're going to do. So nearly all of them were able to do tasks 1 and 2. We offered 3 and 4 to 7 of them, 2 had to run. So the 5 that could stay with us were able to do tasks 3 and 4. And before we taught them this language, we asked them how long they thought it would take. So remember, none of these folks except for 1 had any programming experience. And they were all HTML beginners. So they estimated between a handful of hours and a handful of minutes. Somebody could human on the scale. And the actual time it took them was a couple of minutes, 3 to 6. It's an extraordinary difference in how long they thought it would take. So here's a demo of the finished example. I loaded it with some of my own data. So this is the, I think this is the to-do list. So you load the page, synchronize it with the spreadsheet. I'm going to add, eat some, take, add. Shows up over on the spreadsheet, check something off, so that's true on the spreadsheet. So that was the spreadsheet, or sorry, the to-do list example. Here's the mortgage calculator example. So this has computation in. So we load the web page, synchronize with the spreadsheet, let's change the loan amount on the house. Changes over here, that changes the monthly payment, which is reflected over there. And now if we change the interest rate, it triggers this amazingly fully valid variable, this conditional. So these are simple, but there's a lot that you can start to do once you begin to compose these and build larger things. And it relies on the skills that people already have. So ground and see what and again, back to this mock-up driven development. The UI is just HTML. It's just the mock-up. It's just the way that the designer would deliver it. I'm not a very good designer. But just the way that the designer would deliver it to absolutely steps. So one of our participants, this particular participant had never, I think she had never learned what a database was. And was able to do all the tasks correctly. She said afterwards, it feels amazing. I thought it would take me 3 to 8 hour days to do something like this. And then to be able to just do it with Google Docs, which is something I use so frequently, it can be so easy and makes so much sense. Yeah, it's really cool. And so, juxtapose this against this. So this is the Rosetta Stone of to-do list. I think it's called do.pc.com. And if you make a new web framework, you kind of have to go on here and upload your implementation of the to-do list to this Rosetta Stone. So see how your framework. So this is Facebook's hot off the presses intro to this Rosetta Stone. It's this reactive framework that's supposed to make it easier to make a web application. And this is literally the same to-do list. It's 100% JavaScript. There's no CSS. Well, there's a CSS file. There's no HTML. Let's see, we're generating HTML. Here's like an LI. There's no arg1s everywhere. And so I'm sure this is great for all sorts of industrial applications. So I mean, I don't want to just kind of say that you're not it. But at the same time, it's kind of nice to be able to have this as an option. Where if you want to do a simple information management application, make a simple spreadsheet, simple HTML page, just it seems like we should have this other end of the spectrum. So we've been experimenting with a few more people trying to get use cases for this and slowly roll it out. So here's one example, a self-tracker for high school students. It's a mobile app. And you can enter in different things about yourself, and each person who uses the app gets a duplicate of the spreadsheet. So you show up as a new user and have a server that will duplicate the spreadsheet for you. Now you're connected to your own private spreadsheet. So here's the weight form right here. We connect to the weight. We got some JavaScript that adds it. And the idea is, if this could work for high school science class where you need to gather data, and in your high school computer science class, you learn enough HTML to know what a form is. The hope is that maybe you can start copying and pasting and modifying this yourself and making your own experiments, collecting your own data without having to learn heavy-duty programming. Here's just one board. It's a Neil board. It's state of Delft. There's a fraternity here, and apparently one of their complaints is that their caterer keeps changing the room. So now when they show up, they follow the caterer, and just edit on a spreadsheet. They have this website. It's using access. All right, so wrapping up, this is a talk about identifying and filling what I think is a very important gap in web stack. And that's adding these declarative building blocks for design encapsulation, reuse, and data interaction. The intuition was that these are both facets of this notion of structural relations. So encapsulation and reuse is how these related structures compose. Interactivity is how these structures respond to change. And the approach we took was this declarative symmetric relational language, CSS or structure. And we showed that you can do all of the things that we normally do, template, and implement all of the stuff you need to do. But it also allows these new operating possibilities, mock-up-driven development, theming, spreadsheet-backed web apps. And these are some of the really, I think, interesting things that are possible because we've shifted the model that we extract the problem to one where we can better reason about what it is we're doing. When we smash web content together. So I want to end on this way. So a lot of people, while I've been working this, have come up to me and said, Ted, why are you focusing on text formats? The world has moved on. There's all these cool tools, and you should be focusing on, I don't know, virtual reality or whatever that people do these days. But I thought a lot about it, and I think the reason is this, and that's that the web is the way that we communicate today. More and more, when you read a Kindle book, you don't think of it as being on the web. That's using HTML to display. So increasingly, it's important that we understand how to communicate, express ourselves digitally. And we should aspire to build tools that educate you as a side effect. So if I build a fence 100 times, I get really good at building fences. But today, there's this big gap between creators and consumers. So if I use WordPress to write, I'm a journalist maybe, and I use WordPress for 10 years, I become a really good WordPress user. And sure, that's my job, it's just remote. But wouldn't it be great if we could boil down the basic act of creating a good-looking website in the source format, the original format, so we don't need this enormous application stack. So that journalist maybe one day might consider, I'm going to do this by hand today and see if I can roll this like using the raw formats. And then mere act of doing your job will also educate you. increasingly competent in this other aspect of it. And I think that's a big goal to work for, and I think that text formats is an interesting place to be because they're always going to exist, and they're always going to be that building block that we can use to bootstrap ourselves. Hopefully narrow the gap between creators and students. So that's it.
Time for questions.
So suppose I'm one of these sort of high-value creator types.
Yeah.
Probably not going to like this idea very much, particularly if it means that thousands of people out there on the web are going to be stealing my precious theme and format and stuff. So, I'm curious. I mean, obviously, this is something that potentially benefits consumers.
Yep.
But sort of what's in it for the people who are doing sort of the creative work here of actually building things?
Absolutely, great question. So first I'll just the what's in it for me, and then also the piracy part. So the what's in it for me part, this was largely kind of a HCI-ish programming language talk, and from the standpoint of end-user programming. But when we make something easy, that's great for experts too. I know how to program a giant web app. I would love if I could just put a couple of attributes on HTML and suddenly I don't have to worry about it. So I think there is something in it, absolutely, for experts from a logical standpoint. From the standpoint of hijacking people's designs, with an asterisk on it, I'm not sure if this really makes the problem worse in the sense that design on the web, to some degree of obfuscation, is rippable. And people already actively obfuscate their designs with these uglifiers. And so I think that there's no reason you couldn't use this on the back end. So everything here is described from the perspective of the browser, but a language is a language is a language. This could be the way that you stitch together things on the back end. You could still receive some of the benefits, and I'm sure you could translate these relations to obfuscated relations. And my guess is you could probably find a way to obfuscate, which is kind of the current way to prevent people from ripping our designs today. So I do think it's a problem, but I'm sure there'll be all sorts of ways that, if you're concerned about people working on that.
Do you have sites or themes that are like ready to be used if we wanted to do this?
I'm glad you asked. Well, so we have kind of on the
Because I do
back
know.
burner a bunch of themes. We took a bunch of WordPress themes, created themes project, downloaded all the WordPress themes, and wrote this plug-and chug engine which steps through all these combinations, extracts the HTML mockups and generates PhD. It's kind of half working and got stalled because of some of this other work. But what we hope to do is so there's this whole static logging community. This is a good theming. It's like a first step because they're ready and waiting, busy being CMSE functionalities, and they can have their static logging.
Yeah, I guess.
The answer is halfway.
Yeah, and a follow-on question to that is: so you created this. How is there a thought as to like how you're going to get it out there and get those people who are making the big robots using it, or?
Yeah, open source treesheets.org.
Okay.
It's research code, so I apologize in advance.
Sure.
But I mean, after graduation, I'm going to be working on this and trying to apply it to the spreadsheet kind of stuff.
Congratulations.
Two other questions that have come up. What characteristics of template languages or template systems or template instances make them more or less amenable to the approach?
So, are you saying, for example, what are there things that we commonly do in some template?
For example, if you wanted to advise people, either
Sure.
you talked about obfuscation, if you don't want to do that, if you wanted to produce templates with some CMS services, and what would make them more attractive?
Oh, the opposite. So, like, what if you wanted to design specifically for this? Oh, okay. I can answer the other question too. That's interesting. But if you want to design for this, you need to do the following. Every piece of content needs to be, think of HTML as JSON essentially. Every piece of content, or every semantic object, so like a dictionary, or node, which is a container for other pieces of information, needs to be distinctly selected. So you can't say, if you want to distinctly select first name and last name, you've got to put statements. If you have a set of things, you've got to wrap that set of things distinctly to select the node which wraps that state. So really, I guess one way to think of it is your HTML needs to be isomorphic JSON structure, or you to
And did you find that people were generally doing this? Or?
And I hopefully I hinted at that in a little bit in the example this time. I honestly, my real expectation is that the way we kind of just casually spit out web designs today, you're going to have to edit. I would be very surprised if there was a web page that required zero adaptation. Just because we so commonly commingle concepts. I should say that a lot of these newer languages like Firebase are edging closer to this way of looking at the world. And the closer they edge, the more likely it is that your design to drop.
So my related question, where do I come from to see why I think it's related? One might view microdata markup or RDFA markup as a kind of template for data-oriented data.
Sure.
Have you tried applying this technique to those sorts of?
We haven't tried applying it, and I know there've been some. I think it was RDFA. So philosophically, I think the starting place from this was that at the very root, think from like the selfish what's in it for me. If all you do is mark up your page, that's like the minimum atomic possible activity you can do. All you've done is signal where it is to somebody else. But here, there's a more complicated atomic activity. Because here, there's this requirement that you're drawing relationships, and that other thing is a design asset. But you could draw to so you could use this to just signal solely the presence of data. But the idea was that if we could make the atomic data activity something that also is something you selfishly want, then there's a lower maybe barrier to entry to people who just kind of shrug their shoulders at semantics, which I totally believe it. So you can think of this as like my attempt to make a Trojan horse, where the real goal is to enable all of this nice semantic weaving of information in the page, but the way we'll deliver it is to provide something which, even if all you are is selfish and just want to save yourself time, that activity of annotation will still have
I wish we had.
So you say you run stuff that you are. Usually, lots of people might not do that. So which allow you to actually tweet the data space and say this,
Yes.
you go there. With that would be that or authentication to do that sort of thing. What extent is it that is something you said that it is or the facility looking to the national people, and the related questions to how do you go about the creation of these things liable to it? Have you other solutions for that?
all great questions. First of all, how about with the slight fancy things? Maybe it sounded fancy things are okay, so to the low-level act of saying this is this with accounts, graphical. I think yes, the answer is it's as difficult as that developer mode of your browser. So sometimes it's hard to select something graphically and you just look at so many elements in a cascade or hierarchy, similar geometric boundaries on the page. So I mean that things like that goes a problem, but to the extent that you can select things with a pointer, because these are just binary relations, yeah, we can take this and this and this. To the where does it get very complicated? I think the composition of the relation. So we tried the set of relations that we created. We're trying to evoke this template language view, but it's clear from the spreadsheet example that we come up with several different variants of what relations we're using to describe it. And I think one thing that we have seen, especially with UROPs, we were trying to learn this to create CMS things for us, is that once you start composing, a couple of things get. So one, while it's really nice in this idealized way to externalize the relations, doing so and having this complete non-word removes this procedural thinking that we're used to having, and that can result in a very confusing editing environment once you have too many words. And so I think the answer to that is really not change the language, but rather come up with an editing environment that lets you choose which way you want to go. So I want to look at this as a procedural setting of for each, if this, print this, and then you can export that to this external file with this particular flow. And then one other way in which this can be used is there's plenty of systems, even one step beyond WYSIWYG systems that are looking, for example, wrapper reduction systems that extract themes or the Stanford word number plot and just trying to find mappings from one web page to another. And so that's if I want my web page to work first, we have a machine learning model that just takes it through. So something like this could be used because it provides a language to express the things. So they can give you the language instead of
so that work does generate something else.
So their particular work finds a minimum edit distance between two pages, and then they do this really clever trick, which is that they bias the cost of making an edit based on all of these SVMs they've trained out. And say, this is what a title looks like, this is what a body of a work looks like. So they find this minimum cost edit between one and but they're changing what it means to be an edit based on how likely the two elements are. So the result is you kind of just get out this new page, which is the knowledge. At least my knowledge from the paper, there's no description of why these two pages were particularly. So this would be a way to do that. And then also, machine learning always gets you 80% of the way. So having a format like this fits as a human.
You have content that doesn't exist yet, but you see a design that others are making up with others. How do you decide what stuff is doesn't have existing information?
Sure. So the answer is you can structure it in anything, whatever editing environment that seemed to fit your content that had a wrapper to expose itself as a tree or system, for this system or system like this. So you could express it as HTML, or the relations to the design, express it as a spreadsheet. You can imagine expressing it as a Google Doc with the Microsoft Word, Office 365 doc. So we've implemented spreadsheet bindings, HTML bindings, the principle, whatever editing environment you want, as long as it expresses itself.
Question one, you don't like
Oh. I mean, like it's a tasting or people seem to like text format. Spreadsheets nice. Markdown people like. Markdown is like. YAML, some people like YAML.
Oh, are there ways to like swap parent and child nodes? Like if I have if I'm a professor and I say I list my students and their publications, and then another professor like David lists like his publications and then all of them.
So you can construct, and so there's kind of two separate questions. So the particular parent child would really happen because it's an annotation on subtree. If you made, for example, you made these relations to the top two, what you do is you process the top down down. So you hit this here, you would simply take the subtree down here, and then you never get it. But to the broader question, which is can you construct situations with so there are various things you can construct where it would probably be confusing. And it's not, I think the nature of any, it's possible to construct some statements. So it's you follow things. In the sense of
Some cases have links to a stream, but I just like which they'll page up.
we We right now you have to manually point name and point, and we don't have any support for saying this tree is sort of page 1 and that tree is tree 1. So you can do a very primitive form of things, which is I allocate a tree called the first half, and I allocate a tree called the second half. There's two sets of halves. But no, we don't have any way of saying take this set.
Okay. Well, if there are no further questions, we have to go to the closed portion of the presentation, which at this point will involve kicking out everybody, including Ted, so the thesis committee can talk about it, and then bringing Ted back. And then you'll see if the white smoke or the black smoke.
Wait, when does the smoke come out?
Yeah.
Smoke usually comes. It's a great yeah, I don't know. I gotta go back. That was cool though. I want him to build cool themes so I can use them.
Yes. Yes. Yeah, that makes sense.
Yeah, but like.
We got another thing.
Okay.
Who's on the, who's at this machine?
Oh, I'm sure they'll come back for it.
It's running a Google Hangout?
Oh, somebody was watching.
Oh, Ted set that up. Yes, we need to close that.
I think so.
Okay.